Hey, Xavki here, welcome, and it's a new video, and in this video we will initialize our Kubernetes cluster. So this is the first step, in fact, with our Kubernetes cluster. You will discover it's quite easy, in fact, to initialize a cluster. We just need to do it step by step, of course. Don't hesitate to subscribe to the channel to not miss the next video, like and comment this one. And don't hesitate just to scroll down and have a look inside the video description, because you have a link to the GitLab repository with all scripts, all codes that we use in each video. Let's go. Let's take a look how to do it. So what is the step-by-step things? So the first thing is to just add some kernel parameters about the IP forwarding and stuff like that. Just after that, we will install the Debian Kubernetes repository, maybe with an older version, that will be the 1.32, and after that, we will install Kubeadm, kubelet, and kubectl. That means that we will install it across all servers that we have, or we will have inside our cluster. We will run our cluster CLI initialization with Kubeadm. So it's a Kubeadm init CLI. And right after, we will run our first kubectl apply to install kuberouter, just to ensure that we will have a CNI, so container network interface inside our cluster. So let's go. Let me go over each server. So we have Kubeadm 1, 2, and 3 on the left, and on the right we have our worker. Of course, all steps without initialization and the kubectl apply, we can run all CLI on all servers, just to ensure that we will have our binaries on all servers. So let's go. I can open the script, and like you see, it's a bash, so you can run it like not directly, because you just take care about the initialization of your cluster, but for the other part, you can run it on all servers. The first thing is to set some kernel parameters for IP tables or IP6 tables. That means that all packets will be go through IP tables if we use the bridge. So it's really important to do it. And the second thing, this one, is about IP forward. It's to convert your server as a router. That allows, in fact, to process packets inside the IP tables. So to do that, it's quite easy. We want to push it inside our previous file, so the kate.conf in /etc /cctl.d, and right after we will just run sysctl system, just to ensure that we have all settings ready. Okay, so let's go like that on all servers, because it's a prerequisite. And after that, we will run sysctl with a -- system. And now it's okay. We can check it's okay. So we can do it on all servers. Okay. Perfect. And yes, we can continue. It turns out that right now we need to install, we need to set the version. So in our case, we will use 1.32, but you can try to use the latest version. So it's 1.35 if you want. So I need to do it everywhere, again, across all servers. Okay. And now we can just apply the apt repository installation. So it's a specific repository for Kubernetes, in fact, and we will push it inside /etc /apt/source list.d in Kubernetes list. Okay, so I can do it on all server again. Okay. And as we add a new repository, we need to carry out a apt update right after. So we can do it again. Okay, that takes a few seconds. Now we can install kubelet, kubectl, and kubeadm on all servers. So, and right after we can mark its package as hold, just to be sure that we won't upgrade this package without to take care about the version and so on. So it's really useful to hold these packages, in fact, to be sure to not change the things too easily, in fact. So we want to install it, apt mark hold, and enable the kubelet to be sure that the kubelet, because there is only the kubelet here, which will run forever on each server as a daemon. So to do that, we will run systemctl enable and the kubelet. So it's easy again. There is the installation that will take few minutes or seconds, I hope. So I can run it on all servers again. And just after that, what we will do, we will pull automatically all images that we need to use, and we will be only focused on the first master. So just to initialize, the goal now is just to initialize our Kubernetes cluster. So the first things will be to pull images on the master and the first master. We will set the IP. So this is the IP about our first master. If we check here, so this is this IP, perfect. And just after that, so I can just reduce a bit like that, just to be only focused on our Kubeadm 1. So now we can pull images. And in fact, when we say images, it's like etcd, it's the pose, but we will check and we will have a look into it later. But we pull the API server, the controller manager, the scheduler, of course, because we are master, the etcd, the kube proxy, and the pose container. So, and core DNS as well. So right after that, we will just set a variable for IP, just to set the IP inside the variable, okay? And we will initialize our cluster. So to do that, we will run kubeadm init --API server advertise address. So this is the IP about our current master. And right after that, the --API server cert extra sans. In fact, take care and warned. In fact, it's really bad to do it like that, because that won't ensure the high availability. So we will make a video dedicated to the high availability with HAProxy and so on. But right now, we will just set only one IP here on the API server cert extra sans, but normally you need to set here all masters, all IPs about your masters, and the localhost. And maybe if you use a VIP, a dedicated IP for your Asha proxy on the top of your Kubernetes cluster, you need to add it here. And just after that, we have, I can edit the file, I think, yes. It's not kubeadm1, but it's kubeadm1. Just two networks that we need to define. The first network is the pod network, so the CIDR. We already saw that in services and so on, but it will be the range about 10.200.0.0/16, and about services, we have a dedicated CIDR for that, the 10.201 and .0.0/16 again. That means that for each pod and service network, we will have a /24 for each workers. And at the end, the control plane endpoint. That means that in our case, it's exactly the same IP, but this is where you can set here the IP about your load balancer, for example. Not here, but here and here. It's important to have both. So let's go. So we can install it like that. Okay. So that will take. So images are already downloaded. So it's easy. In fact, it's quick because there is nothing to download, and this is only the initialization. What we can see into it, we can have a look. And here, the first thing is to create. So normally, we can have inside the same CLI the Kubeadm config images pool. This is our previous CLI that we ran, and right after that there is the certificate part. So the first thing is to create a certificate directory in /etc kubernetes PKI, and just create the CA and the key. So the goal is to create a root CA, in fact, to manage the PKI, and right after the generation of each client certificate and the key, because each component inside the Kubernetes cluster is connected to the API with MTLS. And to do MTLS, you need to have a root CA, and for each component, you need to have a key, a CSR, just to request the root CA, to request a certificate from the root CA, and after that, you will have a certificate for the API server, for the kubelet, for the proxy side, for etcd, and so on. And just after that, some check and the configuration, because yes, we use MTLS, and for some component we don't use directly the certificate, but we use certificate through a kubeconfig file, like the classical kubeconfig file for admin.conf, superadmin, kubelet, controller manager, and scheduler. And after that, again, some manifest. So this is for static pods, like you can see here. Static pods, it's when you want to create a pod, but without the kubectl apply, directly through a manifest stored inside the /etc kubernetes manifest. So if you take a look here, you can see we have a manifest for etcd, kube API server, kube controller manager, and kube scheduler. And if you check, for example, the kube API server, like here, we have just here a manifest of pod for our Kube API server. Okay. We have some other things, so the airbag definition and so on, the configuration, the kubelet configuration as well, and right after that, just the core DNS and kubeproxy installation, and the initialization with that is okay. So now what we can do and apply these 3 lines. The first one will be to create a .kube inside the home of our user. So we are with the root user. We can run a cp command to copy the admin.conf. So this is our kube config for our Kubernetes administrator, and we want to push it inside the .kube directory, and right after we will change the permission on it. Okay, so now we can run kubectl get nodes, and this is the first time where our output provide us a cluster, or Kubernetes cluster, but in fact with only one node, so our first master, not ready on status, and we will fix that just right after. And yes, and that's it. And if we will do that in the next video, but if you want to join some other nodes, you can join some masters with this CLI, so Kubeadm join, the location about our API server, so this is our first master, the token, the discovery token CI cert, so this is a hash here, and after that, just to install a master, it's -- control plane. Or if you want to join a worker, you just need to remove the -- control plane. Okay. And now we want to fix the not ready status here. So what happened? In fact, it missed something inside our cluster. So if we run kubectl get pods -a, uppercase A, we have a lot of things, but without core DNS, because core DNS is pending, and without a CNI, in fact, nothing to manage a CNI here. So we need to install a CNI. And to install a CNI, we can install, for example, here, we make the choice to use kuberouter. So we can use kuberouter and install it with this CLI. So it's basic, some manifest inside this YAML file. And yes, you can run it directly. And now, if you have a look here, you can see that we have a kuberouter, and on each node inside our cluster, a new kuberouter will be deployed, because, and we already saw that, we have pushed not one kuberouter pod, but a daemon set. So the alias of daemon set is ds for all namespace, sorry. And into it we have the kuberouter. Let me zoom out. Yes, the kuberouter daemon set. That means at each time that we will add a new server inside our cluster, we'll have a new kuberouter. And now, if the kuberouter is up and running on our first node, it's okay here. We can make a kubectl get node, and now our server is up and running, and we have our master. So we have our cluster up and running. Of course, we need to have now 2 other nodes, just to ensure the high availability, but like I said, we need to set some other stuff to ensure the high availability. We will discuss about that in some videos, and yes, that's it for today. Thank you for following this video. See you in the next one. Bye bye.